Welcome to session 3 of module 16 on blockchain for a smarter energy market. In this session, we'll discuss how blockchain is being utilized in smarter grids across the globe and how some use cases can be, for some use cases, can be a good fit as a technology. Currently, from a blockchain's point of view, the energy market is somewhere around USD $180 million, right? And it is expected in the next 5 years, it will grow to something like 5,000 USDs. Different businesses are actually using blockchain for various things, but then particularly for financial transactions and interactions. Why? Because it offers a secure, and secure channel for doing business, managing data, and all that. Now, it has really made a significant impact on the operational costs and reducing the operational costs and maintaining the data integrity, reducing the capital expenditure for that matter in terms of adoption. That's the reason why globally the energy markets are looking to blockchain as a long-term solution to most of the problems that the current energy segment is facing. There are a couple of key players which are doing some really fantastic work in terms of blockchains in energy segment. Particularly are Powwow Ledger, Private Limited, V-Power, Allo3 Energy, to name a few. As far as blockchains are concerned, blockchains, we have already discussed, they are ledgers on a distributed network of computers. Now, since they are distributed network computers, they do not provide any scope for hackers to try and play with the system for two reasons. One, the blockchain is basically a string of blocks connected to each other, interrelated to each other, which are more like cryptographically hashed, right? So the hash of block 0 will be used to encrypt the block 1, and the hash of block 1 is used to encrypt block 2, and so on and so forth. So the point is, the longer the chain grows, it is absolutely impossible to manipulate or alter anything in the chain, right? And that's the reason, and the best part is, since this is distributed, so there are multiple partners in the business network who will have the copy of the same ledger. So importantly, if any hacker tries to change or manipulate a content in a particular segment of a ledger, it will automatically get invalidated, and it will be of no use because there are so many nice good copies available on a network which can be used from there onwards. And that's the reason it has hardly any scope for a hacker to do anything there. And that's the reason why so many industries are working towards the adoption of blockchain. From our energy industry point of view, blockchain is offering a new tamper-proof mechanism for authentication, authorization, and data exchanges. These are the three basic tenets where we see a lot of adoption in energy grids from blockchain technology point of view. As we now talk, about this particular course, there is already a discussion happening about how smart electrical grid management has to, be self-diagnosing and all that. We have heard so many stories in near past where a couple of smarter energy grids were trying to be hacked, right? And we know for sure that they can be hacked in a certain way, right? Now, smart grids rely on automation and remote access. And because of this, there are a couple of security concerns which we need to deal with, right? Particularly two measures, right? One is the authentication, which is the verification that someone who is entering into the system is a genuine person, is having the right identity to do it, right? Second is the authorization, that the verification that someone who does enter has the authority to do what he has to. So the point is, authentication and authorization are two important aspects where smart grids needs to be tackling because of automation and remote access. If you see, let's talk about a few application areas of blockchain in a smarter grid, right? So first is prevents hacking and malicious attacks on a power grids, right? The set of researchers from University of Oklahoma tried to hack into one of the wind farm owners. They basically took a permission, they went inside the farm, they planted a small Raspberry Pi there, and they actually launched a series of attacks on the, on the particular grid from their own computers, which caused the turbine to shut down, right? Now, what is important as a takeaway from this is they were able to secure access to the wind farm and turn it down completely. And they were also able to do a false feedback, input into the farm operators, and which basically prevented from anybody to discover that the system is being hacked. So there are certain vulnerabilities in that. Now, how blockchain can be a real saver here? Since blockchain has identification security, which is enabled through a public-private encryption with key access. So anybody who is trying to get into a system must verify the credentials, must verify their identity and their authentication to do anything on the network. Right? If key access codes are basically kept safe and secure, blockchain is the necessary technology to really make the power grids safe. Right? There is another application area where blockchain can be really put to a good use. Right? It can become the backbone of a secure and efficient smarter cities infrastructure. Now, with the migration, with the industrialization, we have seen a lot of migration of population towards urban areas, right, in the last few decades, and which actually resulted in acute shortage of basic amenities that a particular city could provide, right? And and the reason is the resources were not able to scale up the way the population poured in and the urbanization happened. So governments world over took to establishing smarter cities, in creating infrastructure for smarter cities and all that. Now, again, how blockchain can help. One, since we're already talking about identifiable identities and authorized access, we can use blockchain for recording and storing transaction in an immutable form, right? Which can make the data exchanges between these distributed gadgets in a very seamless and a cost-efficient way. It can actually provide a security that is very much needed for a smarter city to really work, because as such the entire city is interconnected, in terms of all those devices and all those services which the city offers. Let's talk about a few more application areas in terms of blockchain on a smarter grid, right? A blockchain can really help in creating a peer-to-peer energy trading environment. This is something which is already being worked on with. So what has happened is, since the conventional sources of energies are depleting very rapidly, right? So governments across the globe are looking for alternative energy sources in terms of renewable energies, be it solar or wind or whatsoever. Now the problem is all these small microgrids where all these energies is getting generated, it needs to be fed back into the grid so that people can buy, right? So actually the consumer of the electricity is now a producer as well, right? But the point is, how do you effectively use this energy which is getting generated, right? So for that matter, a blockchain-based system provides for an efficient peer-to-peer trading mechanism for a localized housing complex which is generating some sort of energy, right? So let's say a house X which generates some power, which is generating some excess solar power, feeding it back to the grid, right? Now, since this and all information is recorded on a blockchain, right? How much energy is being generated, how many it is being consumed, at what point in time it's being generated and consumed, and what is the relevant rate at that point in time. Everything, since is all on blockchain, it allows for a seamless and legitimate way of doing, peer-to-peer business, peer-to-peer trading, right? So there is another a good application of blockchain from energy grid point of view in terms of electricity certificates. Conventionally, electricity certificates have been used big time in terms of for trading and all. So on a grid, the electricity is generated from non-conventional sources like sun, wind, or so many other renewable sources. To keep track of how this clean energy is produced and how it can be distinguished, governments around the world have actually created a system based on tradable certificates. We call them as energy certificates. This conventional approach of managing these certificates is really a big task currently, right? So when a renewable power plant generates a units of electricity today, a meter spits out the data and it basically gets logged in a spreadsheet. This spreadsheet is then sent to the registry provider, which gets the data entered into a new system, and the certificate is created. Once the certificate is created, a second set of brokers basically deals between buyers and sellers of these certificates, and some third party then verifies these certificates after they are purchased. So overall, it's actually such a Byzantine system which racks up so much of transaction costs, right? And there is definitely a scope of so much of accounting errors as well in this particular entire process. Now, what if the meter could directly write that particular data which it is generating on a blockchain based ledger, right? So the moment you do that, it provides you a very basic, a sort of a trust that the unit being created or generated is actually the right one, right? So in if we can manage the electricity certificates over a blockchain based network, there can be nothing better of way of handling things like that. Consider a owner of small power generators like rooftop panels or some wind turbines or that. they are not able to maximize their profits because in the current system, they are not able to make distinction between the renewable energy produced and the conventional energy produced on the grid, right? There is a Australian startup called Powwow Ledger, which is developing a blockchain-based platform in order to allow producers to trade energy with on a peer-to-peer network, right? So, for example, in a conventional energy network, takes some 60 to 80 days for an electricity provider to get back the compensation for which he has generated the electricity. In a blockchain based system, this can be almost instantaneous in real time. So that's what is the difference, right? Hence, these small microgrid producers can really make their businesses profitable, right? Take another case, right? There is a company called LO3, which has developed a solution for a place, Brooklyn and New York, where they're already using P2P energy trading, So a neighbor is producing electricity and it is being consumed by some other person on the same lane, right? So since it's so easy to manage on a blockchain-based network, this notion has been made possible. And hence, the entire concept of electricity certificates has been pretty much eased out, right, and simplified. Recently, IBM worked with a couple of partners, particularly Tenet, Sonnen, Van Brom. They joined forces and they did two pilot projects together towards developing first blockchain distributed database for managing electricity grid in Netherlands and Germany. So what Tenet has done is it basically used the permission blockchain network, which used Hyperledger Fabric to integrate the capacity of the electricity, surplus electricity being supplied by the households or the electricity cards, like that, right? So what they did was the energy transition actually had a new source which was basically fed into the grid, right? That was one thing. Second is Tenet is the first transmission system operator to use innovative blockchain technology for managing the entire electricity grid, right? There are so many other ways of using blockchain in this particular scenario. So another way they're doing is they are using intelligent electricity meters for for providing benefits to energy producers and end users in terms of improved data collection, right? Now, what will happen is, since these meters are, but then if these meters are not properly secured, it can be an easy prey to hackers. So the German Energy Agency and the European School of Management and Technology, they have released a publication. They have actually published a paper which shows that blockchain technology can make smart meters more secure, right? And it can actually prevent security gaps by acting as a decentralization transaction lock, right? And then it can also create necessary conditions for peer-to-peer trade, right? Where the locals actually trade energy in a more efficient manner. Now, blockchain has really provided renewable energy macrogrids an efficient way of enforcing real-time differential billing as well, right? So there can be a time wherein you are producing like excess electricity at the night, right, where you're consuming it in the day. So there can be a rate change in terms of consuming of the electricity at two different times of the day, right? So with a blockchain-based system, this overall documentation becomes a lot more transparent, a lot more flexible in terms of people to adopt to it, right? And it is hence far more better than a conventional system. Let's talk about a few blockchain use cases in a smart grid, some more of that, right? So from a grid management point of view, blockchains are really good at managing microgrids and smart grids. We just talked about that, right? And of course, the energy storage. As we just talked about, what if a smart meter can directly log in the units it has generated on a blockchain ledger, right? This is one. Second is on an energy trading front, again, blockchain can be a very effective technology to use, right? Since we already know that the smart contracts or the chain codes are autonomous codes, right? They are once they are configured for a certain business process, nobody can manipulate it, right? So you can be pretty ensured that whatever is being done is actually according to the rules and the contract terms. So there is a lot more trust in the system when there is a trading network based on a blockchain-based technology. Similarly, we can real-time pricing is again one aspect where energy trading can really benefit a lot, right? We just talked about peer-to-peer trading where buying and selling of electricity is being done by the neighbors within the same neighborhood, right? Another important area where blockchain can be used in smart grids is control and security. Grid security we already talked about, right? Another good approach of use can be the compliance monitoring. Now, in all industries, there is a good set of checks and balances being put, and we need to adhere to those compliances and governances, right? Since blockchain is naturally compliant, so the monitoring is made very easy because it is embedded in the system. It's not that you have to have additional measures to do the compliance, which is really a great saving from a manufacturer's, from a producer's point of view. Another good blockchain use case in terms of is payment schemes, right? So you can have some electricity tokens, right, which you can uh, use as barter, maybe buy and sell using those tokens. I mean, even those tokens can be monetized as with the banks there as a fiat currency, right? You can have wallets in which you can actually store those tokens. That's another way of utilizing and making payments over a blockchain-based system. Blockchain can really ease out the cross-border payments, as we have already seen, right? We talked about Trade Lens Network earlier, which talks about how cross-border payments are made simplified and easy and effective in more real time compared to so many days which used to take, right, using a blockchain-based technology. Another very important aspect of blockchain use case is supply chain and logistics in terms of inventory management. Now, if you remember the example of the food security, right, where we talked about how supply chain is basically integrated into the overall retail system, right, you will find that it has really made a lot of difference in terms of realizing the value, reducing the cost, giving a more visibility, making it more transparent that way, right? So there can be so many use cases where blockchain can be really put to good use in a smart grid. And of course, there is another use case towards decarbonization where we can, use blockchain to record all those, footprints which are being generated. In the next session, we'll basically talk about the nuts and bolts of blockchain technology, the architecture of the technology, what are the various components in a blockchain system, and how they actually integrate. We'll also have some hands-on using IBM blockchain and Hyperledger open source project, both in terms of Hyperledger Fabric and Hyperledger Composer. See you in next session. Thank you.